Finally, this is the video where we will actually get building. This will be a faster paced video, but with just the knowledge of this simple workflow, you can earn money with local businesses by offering a customer service AI chatbot. Here in ScullyJaw, I'll give an overview of what's going to be implemented. Let's suppose the user has a doc, which will be this exact doc right here. It has some content. Let's say the company name is blah. What we want to do is send this information over to a vector database. This vector database will be Supabase, so I'll teach you how to configure it and have the table all set up correctly. Now, notice that some companies will already have their list of Q&A. They've been answering the same question multiple times, and they want a chatbot to do that. So ideally, for this specific workflow, you won't be changing this document so much. And it's important to say that because what we're going to set up is exactly a trigger. So this is a Google Drive trigger that triggers the workflow every time this document is updated. We will not be upserting information inside of the vector database. Instead, we will always delete what we have in there and insert new information. So this document can't be something that is updated frequently, or else you're going to have a really higher expense and the performance will just be kind of bad. The idea for now is that this workflow should be really easy to maintain and your clients won't have any struggles, any problems, any upserts that inserted duplicated items in here, and it's just still working pretty fine. So after we send everything over to our vector database, we'll use the chatbot. So imagine this is the chatbot. It receives a user question, so dogs or cats. It interprets this information, searches for it in the vector database. After it's retrieved, it then uses that context to answer the user. I believe this is a very important explanation for you to understand how the documents are inserted and then how they are fetched from the vector database. Let's imagine I have only this as my text. And ideally, this would be a very huge text. But since it's just an example, let's kind of insert this text inside of the vector database. You'll see inside of the actual workflow when we get creating that there's a way to split the text. Because you're not going to insert everything in a single document. But what are these documents? So these documents are divisions inside of the vector database. Let's imagine a X, Y, Z. So X, Y. This is just 3 dimensions. But inside the vector database, you have even more dimensions. But this is just a way of illustrating. And we can use just 2 to make it even easier. So let's suppose we had one document, which is my name is Leo. This document could be stored right over here in the vector. So this is the point of this specific document. The next one will be I like dogs. Let's place that over here. Then the final document would be but I like cats very much. Where do you think this would be placed? Closer to my name is Leo or closer to I like dogs? Probably closer to I like dogs, just because of the similarity it has with the property dogs. So for the vector database, cats and dogs have a certain similarity, either because they are 2 domestical animals or any other property. This will have a shorter distance. And that's all a vector database is. So whenever the vector database receives a question such as dogs or cats, it takes that query, positions it inside of the vector database, and let's suppose it was just placed right here. Then it searches for a range. If I define that I only want 2 documents returned, it will search for the nearest documents and retrieve them for me. I can also select a range. So if I want 90% similarity, the scope would be something like this, which wouldn't retrieve any documents. If I say 70%, then maybe it would find these other documents. So now let's suppose I wanted to retrieve only the 2 nearest documents. This and this would be retrieved. These 2 documents would be one on top of the other like that. And it would be sent to my LLM. So let's get over there. The LLM would see something like this. We set the system so you will receive a context. Use that context to answer the user. Then context, and this is all prompts. What's dynamic is whatever's inside this context. If we said we wanted 2 documents, these are the closest documents. So I like dogs, but I like cats very much. From that, it understands the user is asking dogs or cats. And then from this, depending on your LLM, it would output something. The document says it prefers cats, simply because the second document says, but I like cats very much. And for dogs, I just said, I like dogs. For this example, it could be different if I've selected that I just wanted the first closest document retrieved. Because in my example, I'm supposing that I like dogs was the closest document. And so this wouldn't be available. The only thing the LLM would have access is to the document I like dogs. So it would answer with the document says it likes dogs, despite that not being the correct information. And now you might be thinking, okay, so I'll just make it select every single document, or at least 20 documents. That way it will have the complete information to answer any question it needs to. That wouldn't be cost efficient simply because every single time you're searching for stuff that really doesn't matter. Like in this case, you would use my name is Leo. Why does that matter for this question? Since it has nothing to do with the question and was just inserted because you messed up in the retrieving process. Right, so this was a huge overview of what we're actually doing. Now back to the workflow, this is my favorite part. Maybe I will speed through this, but don't worry, you will have access to this workflow. And if you have any questions, please let me know in the comments. Let's head over here and type in Google Drive. We want changes to a specific file. Select that. Select your Google Drive account. I've just renamed this document to free course for us to track it better. If you select the dropdown, it hasn't updated yet. So just save this, F5, wait for the init and workflow to load, hit that, and there it is. So if you click on fetch test event, this is what is going to be brought back to you, which signals that it found the item successfully. What we want now is to actually see that document. So select docs, get a document. In here, you should set up your credential, select that, resource is document, operation is get. Where it says doc or URL, instead of placing this statically, and it would work, so test setup, you see that it fetched the content successfully. But if you ever change the document you're searching for, like if you change it in here, it won't change for the rest of the workflow. So try to make things in a way that you only have to change them once. And to do that, shorten this, find the ID of that docs, which is right over here, drag it down there, test setup, and you're all set. Now we want to add a Supabase vector store. Add document to vector store. In here, you'll want to choose a embedding. If you have OpenAI configured, I like to choose that. And the model is text embedding 3 small. This is really, really cheap. Even if you have thousands of pages inside your docs, you might waste like cents. So don't really worry about this. Obviously, always worry about your expenses. So track it down in the OpenAI dashboard, but that shouldn't be an issue. Head over to the Supabase vector store. This is where we will create a new credential. For that, I'll create a new project, choose organization. I'll choose this one. Project name is free course. You can generate the password by just clicking generate password here. I'll leave West USA, create new project, and this could take a while, so I'll just stare at the screen, and for you, it'll be just a second. Yeah, this took longer than I expected, but you'll know it's done if you click this button and see everything checked, especially the database. Head over to SQL editor, hit that, go to this link, which will be in the description for this video, grab this SQL, paste it in here. And what you're doing here is creating a table document that receives an embedded vector row. For you to receive that, you need this function match documents. This is the function that by default will be used in NAN. You could change this name, but just leave it as default. And it fetches for the informations you need like this. If you ever want to make even more advanced retrievers, you'll probably change this at some point, but for now, that's it. You'll also create the vector extension for Supabase. So hit the run button down there. Success, no rows returned. If you go over to your table editor, you should see your table in here. If you don't, go back to the SQL editor, hit this, which is what you typed in previously, and just run the table creation. Success, no rows returned. Go over to your table editor, and now you'll see the documents table in there. And inside your credentials for Supabase, you'll place that inside the host input. As for the next field, you have to reveal your service role. Copy that. In this field, hit save. Credential successfully created. Close this model. In the table name, it should identify the documents. Select that, head back to the workflow. And now is the part where you will manipulate the document. Let's use our previous example. So my name is Leo. I like dogs, but I like cats very much. Let's place that in here. Let's go over to document, default data loader. We'll use that. Get out of there. Text splitter. We'll use character text splitter. And the chunk size. So what is this chunk size? This is where I'm deciding how big should each document be. If I want it to be as large as my name is Leo, I have to define a number of characters. So 1, 2, 3, 11, 12, 13, 14. Let's just place 15 in there. Go back, save, and execute this workflow. Notice that it generated 7 items. But why? Since dividing this phrase by 14 characters each, it should give me a maximum of 4 different documents. So when you head back to the actual database, you'll see these IDs. These IDs come from the Google Docs node. See, it outputted that, and so this main node interpreted it, divided it, and placed everything inside of the vector store. To make sure that does not happen, head over to the default data loader, hit this mode input, load specific data, so it's not going to load every single data. Press equal inside of your keyboard. That will use the expression field, insert JSON. Inside this JSON, you have to place whatever is outputted by the Google Docs. To see what's inside there, just deattach this, run the workflow. You'll get the information. Content is what we're searching for. Place that back in. Now you can visualize that, just place a dot, content, and that's the only thing it will interpret. Since we still don't have a node to delete everything from the Supabase vector store, let's head over there, update it to make sure we have everything. Select it all, delete 7 rows. Now test your workflow. Nice, now it retrieved successfully 4 items. You can check in here what was the division. So my name is Leo, I like dogs, .b, I like cats very much. Nice. Now, instead of doing that process of deleting the Supabase vector store every time manually, let's do that programmatically. So head over to Supabase, select Supabase there, delete row. In here, you should select a type string. For this type string, we're going to place a ID equals to greater than .0. So everything that has an ID greater of 0, which will be everything, will be deleted. So I just noticed I did something pretty wrong here. If you test the workflow, all this is executed, but then it doesn't follow along, simply because this field is expecting a JSON content, and since it doesn't have that, it just stops the execution. What we want to do is grab this, place it over here, patch that, delete this connection, and now this won't see the JSON ID. For me to get that information, we'll use Google Drive trigger. But as soon as we execute this, you'll see it stopped here. So just go over to settings, always output data. Also make sure to come over to the Google Docs node, select settings, and execute once. And that's because the Supabase node will recognize more than one item. So if you test this workflow, it identifies 6 different items, and it would force this node to run 6 times. And if it runs 6 times, it would have 6 times anything that's inside of your documents and send all of that to the Supabase vector store. I've just made ChatGPT generate a whole Q&A for me, and this is only 3 pages long, but let's see how that works with our workflow. Instead of splitting 15 characters, ideally this should be way more, so 400. And the chunk overlap, let me explain this while we're at it. The chunk overlap kind of works like this. Let's say we have these documents. If I didn't have chunk overlap, the first document would be this one, the second one would be this one, and so on. If I choose to use the overlap, then it would rather be my name is Leo plus, let's suppose, 3 characters. So it would be that. And then the second document would be this. The third document would be something like this, and thereon. But for a short sentence like this, it doesn't make sense at all. It makes way more sense when you have complete phrases like these ones and have correlations to the previous nodes, because this way you have better context of what's happening. For this case, we only need each section. So the question and the answer, but let's keep it basic for now. So just select 400 characters, hit save, test workflow. It's going to fetch everything from Google Docs, delete it first from the Supabase. So this is what we got. Notice that we have a question and an answer in the same document. Actually, 3 answers and 3 questions inside the same document. If we wanted to instead separate each question and answer for one specific document, we can do that inside the character splitter. So since between them we have a /n, we can place in /n in the separator here. And just for testing purposes, I'll show you that this actually does not work. you get only one item, and that's because it's not identifying the /n. I found in some forums that if you type in enter after this, or inside the expression, place this enter right here, it should work. But for me, I haven't had a lot of success with it. The best way I've figured out to get out of this error is just typing in a expression of /n string. And when you have that, save it, test workflow, and now it should successfully interpret every single /n you have. So now you see that you get the actual Q&A. So question, answer, and it's trying its best to divide through each /n. There are areas like this one that it wasn't divided, but that might be because of the chunk size, but it might not matter that much for the majority of the documents generated. Now we want to talk to that data through a chatbot. Add a chat trigger, and relax, we will attach this to WhatsApp pretty soon, but it is just faster to test this out through n8n first. Question and answer chain, grab that, place a model of, let's use Gemini. This one Pro experience can do the trick. Now we'll set up the retriever, and there are multiple retrievers. I won't cover this for this tutorial. I think it's a bit more advanced. So just go with vector store retriever. This limit is how much documents you want to retrieve. It's what I was talking about in ScullyDraw. Vector store is the Supabase vector store. That is the Supabase account. The table name is documents, and that is all set. For the embeddings, you can drag this over to the same node. And ideally, this is not single responsibility. This is just because I want to share this workflow with you guys. Ideally, you would separate this. So you would grab everything in here and place it in a different workflow. And also, while we're at it, let's rename this to WhatsApp AI Chatbot Integration. Actually, this embedding down here is really ugly. Let's remove that, leave it up there, drag it down here. It's the same exact embeddings. This embedding is now converting whatever the query is. So it's getting this query right here, transforming it into a vector. So it needs to be the same model that you used to store it in the first place. Just by setting this up, I believe that it might work. So if I ask something from the Q&A, do you use organic, or let's make that question. It will search everything, and it got me an error. That's awesome. Let's figure out what happened. For me to log through the errors faster, I just hop inside the question and answer chain. If I were using an AI agent, I would go inside of its node because it has everything. So it has the complete log of everything it did. And the problem seems to be from the vector store retriever node, error searching for documents. So it doesn't have that function that we used earlier. This is the function. Let's send it over to our database again, SQL creator, place that in there. Don't create another table, because if you try to do so, this won't be successful. Now that I entered the function in here, it might just work. Close that. Let's reset the chat and make the same exact question. Now it has the function to search whatever I need it to search. It provided everything for the question and answer chain, and this is how you can understand what it had access to. This part of the Google Gemini chat model is exactly what I was explaining over here. The system message of use the following pieces of context, this can be found right here. You can edit that. You can do whatever you want with it, like make it answer like a parrot. And what we got here was the most similar documents to the question made. Since I wanted 4 documents, these other ones were retrieved. Then I get the human question, and finally the output, which was figured out by the LLM. So the RAG part is pretty much done. Now we have to add a webhook. This webhook will be our trigger. Get it over here, make it the post trigger. So post. Now open up Evolution Manager, because you will have to select a different webhook. You can have multiple workflows that does different things, but for now, let's just have one. And the path for this will be free course altogether. This generates a production URL, which is this. I go over to the URL field, fill that in, save it. And now it's listening to our WhatsApp. Every time we receive a message there, it will send it back here immediately. Save that, activate your workflows so it works in production. Head over to your WhatsApp, send a message like hi, and this will fail. It shouldn't respond anything back to you, but you will find its execution right here. So this is the failed execution. I can select this webhook, get whatever is inside of that fetch, go to my editor, pin that information in there because this way we could access it in the other node. Save that, add a different node, which is the Evolution API node. So in the Evolution node, you'll select message down here. As soon as you select that, place in the instance name, which will be course. Let's type that in. Recipient number is whatever you get from the webhook, and then from the remote JID. I erased mine because I don't want to expose my number, but it will be inside of this string field. The message is an expression, and you can drag this text over here. That is a response you'll get back in your WhatsApp. Save that, head back to your WhatsApp and ask a question like friends or how I met your mother. If you don't get a response back, probably an error occurred. And for you to check that, head over to the executions tab. The last one here is in fact an error, and that error is because of my prompt. So since previously I was using a chat node, it was predictable. And since it's not now, I have to grab the user message from the node. So conversation, it just sent a hi, save it. So now if I head back to my WhatsApp, I can make that same question. Wait a while and it should answer me now. I don't know, the context provided doesn't contain information, and that's just perfect because it will ideally respond based on the knowledge it has. So let's get a question here such as, can I bring my own hairdryer or product? Send that down. It should go over to the database and find we prefer to use our professional products. And that is what we have over here. Notice though that the question and answer chain does not have a memory. So if I ask something like, what was my last question? It won't know that. So your last question was, what was my last question? Because for him, this was actually the last question. For you to have memory, you will need to use an AI agent for conversation. So conversational agent, select that, integrate everything you had previously, attach this, and now since you don't have a retriever for this specific AI agent, just select Supabase Vector Store as a tool. It has to be with the retrieved document as tool for AI agent. The name of this can be something like you have company data that should always be searched for to answer the clients. As for your table name, select documents. The limit will still be 4. You can or not include the metadata. This is a bit more advanced if you're actually going to use the metadata, so don't include that. And for this part, it's done. Let's drag this down. The embedding will be the same from down here. And you can remove this connection. So drag this down here just so it doesn't get in the way. Don't forget to change whatever the input is for the AI agent. So hop in there, select define below as an expression, place in that expression. And now is where we get to attach the memory. Let's drag this down and use Redis chat memory. The context window length is how much of the previous conversations will be sent over to the LLM for it to understand the overall context. The session time to live are seconds that will be available as a context. So if you want all the data to be erased after an hour, it will be 3,600 seconds. Save that. In here, you'll have to place the key, which is the unique identifier. You can use the person's phone number. So grab that down there, head back to the Redis chat memory, use an expression, place that in, and now your chatbot should have memory. Let's say something like, hi, I'm Leo. Didn't answer, I got an error, and that's completely normal. It's because now the response from the AI agent isn't a response.txt, it's now a output. So placing that in, and now saving the workflow, heading back to my WhatsApp, saying the same message, hi, I'm Leo. Now I hope to get a message back. Hi, Leo, I'm glad to be assisting you today. How can I help? I can say something like, what's my name? Your name is Leo, as you stated in your introduction. So now we have a complete workflow. I'll delete this and this because I feel like this is a more ideal workflow. I'll download that and share it with you guys. But remember, this is a pretty simple workflow. The magic is of how you're going to adapt this for each specific need. And as you continue building more features into it, solving a lot of bugs that might appear, you will gain more expertise and your value as a AI automator will just increase. Thanks for watching. If you have any questions, feel free to ask them inside of the community, and I'll see you inside of those posts. Till then.